I've been involved in indoor air quality for 30 years or so, both measuring on a proactive basis. That is where people don't know they may not have an issue, but they want to be ahead of the curve and finding out early on if there is an issue. So we do a lot of measurements in commercial buildings where there are no known problems, and we're trying to identify issues early on. And we also do a lot of investigative stuff where we get inquiries and complaints from people suffering from indoor air quality, so quite a bit of our work comes from that too. Around about shortly after BREEAM 2011 came out, we started getting inquiries for testing for VOCs, volatile organic compounds, more of which later on. Because that's you get credits under BREEAM for that. So we set up a little specialist arm called Air Quality Plan. Today I'm going to try and tell you about some of the stuff that we've learned from the commercial monitoring that we do. We very rarely get involved in domestic scenarios, but some of the lessons that we've learned are very appropriate to domestic too. A lot of these things you're going to know about already. Hopefully you'll pick up on one or two things and get some reassurance that you're doing the right things anyway. So there is a lot of guidance available in the commercial air monitoring side of things, going back quite a number of years, far less so in domestic area. You'll notice the WELL standard is here. Yes, I agree with Claire that I think this is going to become a very big thing in the UK. Even though it's an American standard, I think it's got a lot of resonance, and I think that it will also be echoed in BREEAM in use quite closely. So yeah, it's got a lot to offer. So what is safe? There are time-weighted averages, TWAs. These are often measured over 8 hours and represent normal living/working conditions. You get short-term exposure limits, or STLs, which are usually measured over 15 minutes. These are normally a higher safe, what's deemed to be safe limit. And you get something called, which I didn't know about until the other day, and you get something called ceiling limits. Now, I'd never heard of this one before, so I thought I'd better look it up. These are an upper limit that thou shalt not breach for any period of time. And these this data, these limits, are all issued in a guidance document published by the Health and Safety Executive called the Workplace Exposure Limits. But the bottom line is that nobody really knows what the long-term health effects are of exposure to low levels, that is below what are published safe limits. Nobody really knows what the health effects are on people if you're exposed to these pollutants for a very long time, such as living with them or working with them. What we do have is fairly well-educated guesswork. There's one thing that's fairly sure, that as medical science advances, the limits are only likely to get tighter. They're not going to go the other way. The limits for certain pollutants, as we discover more about the effects on people. But it's also safe to assume that any improvements that we can make on indoor air quality in design can only be a good thing for the health of people. There has, of course, to be a balance between improving the indoor air quality and the energy efficiency of the building. But really, that is my first point, and I'm going to give a series, I hope you forgive me for giving them in the form of a tip. I'm going to give a series of tips. And my number one tip for improving indoor air quality is to design the ventilation as well as you can possibly do so, exceeding the building regulations if you can, and to get it as good as possible. When I mentioned that we get invited in to investigate complaints of indoor air quality, insufficient fresh air ventilation is the biggest cause of those complaints, where designs have changed over the original or have just not been designed with enough fresh air coming in. And this leads to smells building up and pollutants from people building up and generally creating an unpleasant atmosphere. So my number one tip is improving the ventilation to the most you can get it. There's a fairly high chance that one of these kind of issues is going to be somewhere near your site. Particulate matter can travel a long way, and I'll just talk a little bit about vehicle emissions for a minute. You may remember that about 15 years ago, the car industry were busy patting each other on the back and extolling the virtues of diesel car engines about how clean they were, and saying that their particulate emissions have massively dropped. Well, they had, but what they were doing was they were judging the results against what's called PM10 measurements. PM10 is 10 microns, which is 10 thousandths of a millimetre particle size. Those were the standards that they had in those days, and you needed very specialist equipment and very expensive equipment to measure anything smaller than that. But they were getting the numbers, the PM10 numbers, to drop because basically what they were doing is they were making their engines grind the particles down to even smaller. And these smaller particles are far more dangerous to health because they can travel further down into the lungs. So they were giving out this image of lovely clean diesels, but in fact they were making the problem worse. So these smaller particles can travel over greater distances because the 10 micron size by today's standards is basically boulders. You're measuring boulders. So 10 microns are really, really small particles. The smaller particles can travel longer distances. So that's my point. So it's worthwhile taking these kind of things into consideration in your design. And so that's my tip number 2, is to consider sources of external pollution and to design accordingly. So the air intakes on the other side of the building or as far away as possible from those sources, and to design the filtration accordingly, making it as good as you can afford to have it, taking into account the cost and maintenance of those things. We can talk about radon now. This is a gas that seeps through from the soil. It's a decaying uranium, and it is linked, another little known fact, to something like 1,100 cancer deaths in the UK a year. The solution to it is to provide, it's a fairly simple solution, is to design in underfloor ventilation. So if you have a void or create a void under the building and ventilate it, either naturally or forced ventilation. You can. It's much more widespread than you think. People say, radon comes from granite. Granite is in the southwest. That's all I've got to worry about. If I'm not in the southwest, I'm going to worry about it. But actually, you do. There's a map. I should have put the map on the talk. Sorry for not doing so. And it's very graphic. It shows in red all the areas where radon is a high risk, and a lot of them are in the southwest. But there are pockets around the place, around the UK. You can, and here's my tip number 3. You can go to that website and put in the postcode of your development, and it will give you, and it costs peanuts to do it. And you can, on there, it will tell you whether you're high, medium, or low. It won't dictate to you how you're going to address that, but that is a good starting point. You can do a radon test. It's relatively inexpensive. So that might be stage 2, is to do a radon test if you're in a high area. I'm going to talk about flexibility now. You can still get indoor air quality problems even with well-designed systems, and these are some images of common causes. The top left one is a picture of a guy sticking a carpet down. What you introduce into a building, if you having new carpets installed, for instance, they are going to give off volatile organic compounds, and some of these VOCs can be harmful to people. Again, I'll talk some more about that in a second. And so the other picture top right there is one of mould, and this comes about through excess moisture, either as a result of a leak or condensation. So back to the design issue again. And you don't need very much change in moisture to get mould, bacteria, fungi accumulating in your building. And this is a fairly extreme example where it's actually visible. A lot of the time you get moulds present, but they're not getting to the point where they're sticking and showing up on surfaces. You can do mould tests where you draw in a known volume of air, pass it through a collection media, and then culture it in the laboratory, and so you can get a reading from these things. But the answer is to design well enough to have adaptability in your ventilation system, so that if you start to find excess moisture, condensation and so on, then you can do something about it early doors, so it didn't get to that point. And the third image isn't a great example of occupancy changes. In commercial buildings, we find that if you've got a room that is suddenly being changed from an open plan office with a few desks in it to a call centre where they've crammed as many people in there as they can possibly get in, then you get a change in the CO2 that's being breathed out by the people, and the ventilation system can't cope. So you get issues arising from that with high CO2 levels causing nausea, headaches, low productivity, and so on. So flexibility is my tip number 4. To design your ventilation system so it's adaptable so far as you can. In a house there's only so much you can do. You're going to have windows anyway. In a commercial world you may design a building with relying entirely on mechanical ventilation, but it's good to have natural ventilation options. Volatile organic compounds, now I'm going to come back on that. These are some of the sources that you might get it from. Sealants, I'll give a more comprehensive list in a second. There are over 10,000 VOCs. These are carbon-based products that are a gas at room temperature. Many of these are not dangerous to health, or not known to be dangerous to health. Some cause minor irritation, and a few can be linked to serious health issues like cancer. They're found in many building products. There's a list there. Paints and varnishes, fairly obvious. Wood panels, so MDF, plywood, chipboard. Timber structures where they've been glued or laminated together. Wooden flooring, parquet flooring. Any kind of laminated floor covering. Suspended ceiling tiles, adhesives, and wall coverings, to name but a few. That list is straight out of BREEAM's HEAO2 guidance. And so tip number 5 is to design from using a green product guide. That's just one example. Where manufacturers will apply to join the guide. They're producing products that they are either low or zero VOC emissions. And followed swiftly by tip number 6, which is to thoroughly flush the building with fresh air before occupancy. We do quite a bit of testing in commercial projects where they're getting rewarded with a BREEAM credit for post-construction testing before occupancy, and these sometimes fail. Despite lots of advice given to project managers before we come, stated as strongly as we can, you get there and you find that they haven't carried out the flush of the building. So you've got a room full of pollutants that have been building up for a period of time, and it's trapped in there and then we come along and do a test in it. It's not surprising it's failed. So flushing out a building before occupancy is a really good idea, and recording the fact. Oh, not too far. Again, coming back to BREEAM commercial projects, they're rewarded with a credit for doing the testing. You don't even have to pass, which is kind of weird. You can still get the credit just for doing the testing, whether you pass or not. What you do have to do is, if you don't pass, you have to carry out the remedial action that is then recommended, which might include retesting, it might not. But this can be a voluntary badge of honour for housing projects and other sectors. You don't really necessarily need to test all the properties, just a proportion, a representative number. And it's a quite crucial point here at the end here, that if that building is later associated with complaints of related to indoor air quality, sick building syndrome and the like, it might be really useful to be able to go back and prove that testing was done, and at that time of handover there wasn't an issue. And that then, therefore, any issues are likely to have come up as a result of occupancy. The occupants themselves will introduce VOCs, as we saw with carpets and things, but their furniture, their clothing, they themselves, the things they do in the buildings will create VOCs. So that evidence to prove that at handover it was clear could be jolly handy. So tip number 7 is to consider post-construction testing for volatile organic compounds of formaldehyde. Formaldehyde is one of the nastiest VOCs, so that's why it's specifically mentioned. And commercial projects are rewarded with a BREEAM credit for having an indoor air quality plan to kind of wrap all this approach up in. And this can be another voluntary action that the developer could use to show that indoor air quality was right at the forefront of the thinking from the design stage. And it could form part of a company policy on indoor air quality. So my final tip is tip number 8, which is to produce an indoor air quality plan from the outset. And then summing up, there's my list of tips. And I think that's it. So all that remains for me to just wish you a good air day.
Yeah. Fantastic. Thank you, Roy.